In this video, we'll show you how to use if statements to model new product sales. So essentially, the most common model of new product sales is the product life cycle. So you can start with a blank file here. Sales go up for a while. Then they decay for a while. And the two industries where I've worked with Fortune 500 companies on this are the technology industry, without naming the companies, and the drug or pharmaceutical industry, not Breaking Bad. Okay. So what parameters do you need as inputs to model the product life cycle? Well, let's think about that. And then we'll generate the sales during each year of the product's life, where sales go up for a while and then they come down. Well, you need to know year one sales. So let's suppose that's 10,000 is your best guess. You need to know years of increase, like how many years will sales go up. So let's suppose that's 3. We're going to assume the most years the product could go is, let's say, 15 years. And then you need years of decrease. And let's suppose you think it's going to be 7 years. And then we'll see in a couple of minutes, we'll need to know total years of sales. But that's easy. See, if you go up for 3 years and you go down for 7, you have year 1. So it would be, we're going to name these ranges in a couple of minutes, okay? So it would be 3 plus 7 plus 1. And then how do you model how the sales change from year to year? Well, you have an annual growth rate when sales grow up. Sales go up, not grow up. Let's say that's 8% a year. And then you have an annual decay rate. And usually sales will drop off quicker. Let's say that's 14%. But these will be inputs that we can change. So I'm going to name all of these. Formulas, create from selection, names in left column. And then total years of sales will be 1 plus years of increase plus years of decrease. And we'll assume we're not going to go above 15 there. But these are all inputs, and we'd like to generate the sales every year. And we'd like to have blanks if we don't sell that year. So in other words, we're selling for 11 years, so we should have 11 columns of data, years. Well, it's easier to make it going down. Okay, so we'll have year number, and so this should stop after 11, and then we'll have unit sales. Okay. So what I could do is have a sort of a a 1 through 20 here as our possibility. Actually, yeah, we'll put a 1 through 20 there. There's a more complicated way to do this, but this should work. Okay. But went down too far there. But if what's in that column is less than or equal to the years of sales, then we're going to put the year number. Otherwise, I'd like a blank. So in other words, what that does, okay, see, it cuts it off at row 11. And if I would say sales go up for 4 years, it's going to cut it off at row 12. Okay, now year 1, the first year of sales will just equal year 1 sales. Okay, now let's think about this. If we have 4 years of growth, then basically sales go up in years 2 through 5. Okay, and then they go down for 7 years in our model here. So how can we model sales? We could do an if statement saying if there's a blank in column E, put a blank in column F because we're not selling. Then we could check, is the year we're in less than or equal to 1 plus the years of increase? If so, sales grow up by the growth rate. Otherwise, sales drop by the decay rate. So I'd say if the year we're in is greater than the last year of sales, okay, so notice in this case that would be a 13, then we want a blank there. Oops. If the year we're in is greater than total years of sales, we'll put a blank. If the year we're in is less than or equal to years of increase plus 1, then we're going to take the previous year times 1 plus the growth rate. Otherwise, we'll take the previous year times 1 minus the decay rate. And we just have to check, does this work? Okay, now I got 2 ifs. I'll need 2 more right parentheses, and I think that should work. Okay, so their sales go up 8%. Let's copy this down. I can double click the left mouse. Let's see. So I got 4 years of growth. The sales went up 4 years through year 5. Then they start decaying. They should decay through year 12, and then they disappear. So I could change this. Maybe sales go up 4% a year. They drop 6% a year, and only they go up for 2 years, and they go down for 4. Okay, so then this cuts off after 7 years of sales. See, sales go up for 2 years, and then they drop for 4 years. And this provides a really nice way to model unit sales, which of course is a key driver in capital budgeting to decide whether or not capital budgeting is computing net present value or internal rate of return of a project, deciding you should go ahead with it. And so you can come up with a nice estimate based on unit sales and your average selling price and your unit costs, figure out how much money you're going to make and do an NPV or an IRR and see if the product is profitable after putting in what your capital costs are. And in the pharmaceutical business, and let's say the Silicon Valley business where you're making computer chips if you're Intel, or making other products that like making stuff that goes in phones for Apple, then basically you need a model that basically follows this, where you ramp up your sales of a new drug or a new computer chip, and then the sales ramp down until they stop. And really, based on the sales and the revenue estimates and the cost estimates, you can figure out whether the product's a good idea or not. You remember the show Animaniacs, some of you? Animaniacs, great cartoon show in the US. Animaniacs. I'd heartily recommend, if you've got kids, the Animaniac Christmas special. They would always say, good idea, bad idea. Fireworks on Easter, bad idea. Maybe you can get that on DVD now or on Netflix, I don't know. But see, this shows you the power of if statements. We wrote an if statement to cut this off after the last year of sales. Then we wrote an if statement to generate the sales volume. Without an if statement, without knowledge of if statements, how do I do this? I have no idea. Okay, in the next video, we'll learn how you flatten a table. Okay, and you'll see what that means. It doesn't mean you use martial arts or black belt to sort of smash a table, but you flatten out an Excel table. Okay, and we'll see how combining the index function and if statements makes that a piece of cake. And I'm hungry for some cake right now.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytics stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.